Okay, so before solving equations involving radicals, I realized that there's only a few examples in the notes, so I'm gonna go ahead and do this one. I said I would do it in the Zoom session, but let's do it right now. It shouldn't take us too long. 2 hours later. Alright, so let's multiply here. This time, as I said in the previous video, I want to get rid of the radicals in the top, which is contrary to whatever we've been doing. The technique is the same though. We're going to multiply and divide by the what's so-called conjugate. Again, remember I don't like that name, but what can we do? And we're going to go ahead and remember that this, if you think about this as a minus b, and then this a plus b, when you multiply them, it is a difference of squares. So you're going to get the square of the first, which is a square root, minus the square of the second, which is another square root. The second would be just the square root of x. And again, I'm assuming all variables are positive. That was the assumption here on the problem. It's not visible right now because I started this video halfway. So you get that right there. And what you do now is, well, you operate here, and since all the variables are positive, as I was saying, the square and the square root cancel and just give you x plus h. That would be the first one, minus the square of the second, which is going to be the square of the square root. Since x is assumed to be positive, it's just going to be x. And then we're going to have h that still multiplies that sum. And this, by the way, this is done in this way for a very specific reason that will become evident when you take your calculus class. So x minus x cancels, right? X minus x just cancels and gives you an h. And then we get h times square root of x plus h plus square root of x. And now h multiplies everything and h divides everything, so you can cancel it out. And by the way, h is not equal to 0, because if h is equal to 0, you have 0 divided by 0, and you know that's a problem. But in this case, we're assuming that h is not equal to 0, so we can cancel it, and we get 1 over. And what happens is, in calculus, you will have a way to make sense as to what would this quantity approach as h approaches 0, which is going to be called the limit. And at that point, then this expression is very much simplified, or much better simplified than what we currently have. Again, right now it looks like we did the opposite, because we started with the radicals in the numerator, and all of a sudden we have them in the denominator where we said we didn't want them. So, but as I said, this is related to something in calculus. For that reason, we have that example there. All right, so let's go ahead and solve some problems, some equations involving radicals. So for example, here, if you have a cubic root, what you would do is you would cube both sides. So you have your cubic root, you then cube it on both sides. Again, you have a cubic root and a cube. This is an odd power. We don't care about the signs. It will cancel anyways. So we get 3x plus 1 equals, and be very careful because some people mess this one up. They say cube, oh, it can't cancel the sign. No. The odd powers do not cancel the sign. You get -8. That's the only thing to be careful with. Subtract 1 on both sides, and we get 3x is equal to -9. So I'm gonna, that's gonna be tight. I'm gonna divide by 3 on both sides. So 3x equals -9 divided by 3 on both sides. And I get x equals to -3 when I get the division, and that gives me my solution. Now, I do gotta want to verify. You see, whenever I plug in -3, I get 3 times -3, which is -9 plus 1, -8, and the cubic root of -8 we computed before, which was -2, so it works out. Now, why am I doing that? Well, because at some point, whenever you square, and we'll see it in the next example, but so whenever you're doing an even power, you may end up with the square root of a negative number. And if that happens, then that solution is not good. Let's check how it works. So that's good, possibly going to happen here. I haven't solved the problem, so I don't know, but I'll assume it will. In any case, let's grab this and square it on both sides. All right, so here, the square root of, and we're squaring it, so we're going to have that coming out, and we're going to have that. Now, right here, notice that I was not careful with the sign, and I am going to possibly be introducing a little bit of a problem, and that's going to come out here in 1 second. We'll take a look. Let's go ahead and put all the variables in one side and all the numbers on the other. We're going to solve this by using factoring. We could also, if we wanted, we could solve it by completing the square like we did before. So we're gonna use factoring. So I'm gonna subtract 15 as well on both sides. So when I do that, I get 15 minus 15, negative 2x plus 2x. So I get 0 here as I wanted, and I just get x squared plus 2x minus 15. So I'm gonna go ahead and solve by factoring. As I said, this is going to be x minus 3x plus 5. Those are the numbers that I need to plug in. So whenever I add them, I get positive 2. When I multiply them, I get negative 15. So here's where I was talking about. Here's where it's going to come out. We set each one of them equal to 0 because remember, if two numbers multiply to 0, then one of them better be 0. So either the first, x minus 3, or I don't know if I should use either because that sounds like there's a dichotomy and there's not. You can have both. So you get x plus 5 equals 0. So in this case, we get adding 3 on both sides gives me that x is equal to 3. That's one solution possible. I have to check. And then x equal to, oh my bad, subtract 5 on both sides. I'm already going to write the solution. And at that point, we get x equals to negative 5. And so what I said is I need to check that things are working out. How do I do that? I plug them back in. So for example, with x equals to 3, I would get 15 minus 2 times 3, so doing minus 6, is the square root of 9. Square root of 9 is equal to 3, which is when I plug here x, it works out. So that one is good. However, when I plug the next one, I get 15, square root of 15, minus 2 times negative 5 equals, what is that? Well, it would be plus 10, so 25. Square root of 25 is 5, positive 5. But here, when I plug in the value of x on the right-hand side, I get negative 5. And that issue is the reason why this is not working is because when I square it on both sides, I'm kind of ignoring both signs. And so I'm introducing a possible error. So I gotta be careful and verify that my answers do work. So this one right here does not satisfy the equation. It looked like it would, but it doesn't. It's off by a sign, and that is introduced when I squared it. So clear that one out. That is not a solution, and this is your only solution. X equals to 3. All right, so let's keep going. So what happens here in the next one? So that was a fail. I went ahead and explained this one, and then I realized it was not on the screen. Oh well, happens. Anyway, so here we already have taken the fourth root. So in this particular case, we compute it and we get our solution. So in this case, remember that the fourth root of 16, remember that 16 is 2 times 2 times 2 times 2, so 2 to the fourth. So this one worked out quite nicely, so you can cancel and you get 2. Now, this one, it's a bit different because you say, well, I already have the cubic root. Well, but you have x there. So that is how you would address something like this if there would be some other term, if it's not just straight up a number. In this case, then I cube both sides. So I'm going to get the cube of cubic root of x, which is going to give me x, and here x cubed. So I'm going to have the equation x equals x cubed. Now remember, last time I told you that you don't divide by x on both sides and get x squared equals 1, because that would be a problem. That would eliminate one of your solutions, which is x equals to 0. Instead, you can subtract x on both sides, and you get 0 equals to x cubed minus x. Then you factor, pull a common factor x out of this one, so x squared minus 1. And then you have a difference of squares to deal with, so you factor it further, x minus 1, x plus 1. And now you have three numbers, x, x minus 1, and x plus 1, that multiply out to 0. So that means that at least one of them gotta be 0. So you have x equals 0. This, if you would have divided both sides by x, as I said before, you would have eliminated this solution. So that would have been a problem. Then you get x minus 1 equals 0. That's the other option. Or x plus 1 equals 0. And now we can add 1 on both sides. And we get that x is equal to positive 1. That's one possible solution. X equals 0 is another. And we're going to go back and check. But since these are odd powers, you'll be all right. But it doesn't hurt anything to check. So always check. And so we get this. So if I plug x equals to 0, the cubic root of 0 is 0 equals 0. So plugging x equals 0 gives me 0 equals 0. No problem whatsoever. So that one is a solution. Now, when I plug x equals to 1, I get the cubic root of 1, which is 1 equals 1. That's a solution. And lastly, when I plug negative 1, the cubic root of negative 1 is negative 1, which is equal to negative 1. So since I raised everything to a power of 3, and 3 is odd, and odd powers respect the signs, then I had no difficulties like I had before with the quadratic one. But, you know, it's best just to check. Whenever you're raising to some power your equation in order to solve it, just verify that you actually get whatever you get is indeed a solution by plugging it back in. It's just better to do it. All right, so that's that for this lecture, guys.